In this lesson, we are going to be looking at solving radical equations. So what we're going to have is we're going to have a radical and a variable, and we want to basically solve for x. So here we see the square root of x is equal to 8. So you could think to yourself, now the square root of what number is equal to 8? And obviously that is 64. But you'll need to know how the process works as we go farther into this. So when you're solving for x and it is being taken the square root, you have to ask yourselves, what is the opposite of taking a square root? And the opposite is squaring. So what we want to do is square both sides of the equation. Now when you have one side that is, you're taking the square root of something being squared, these cancel each other out. So you're left with x. And then of course you're left with 8 times 8, which is 64. So that makes sense because the square root of 64 is 8. But we're still doing our inverse operations and we're still solving for x. So that's a basic one. All right, so now we think 4 times what number, and then we want to take the square root of that and equal 6. Now this is one you could probably sit there and think about mentally, but you still need to know a process for when we get into ones that are a little more difficult. So remember that we're solving for x. And for x, we're taking the square root of it, and the opposite of taking the square root is squaring. And what you do to one side of the equation, you have to do to the other side of the equation. So on the left side of the equation, 6 squared is 36. And when you take the square root of something being squared, they cancel each other out, and that leaves 4x on the other side. Now x is being multiplied by 4. So we do the opposite inverse, which is dividing by 4 on both sides. And that leaves us with x is equal to 9, which makes sense because up here, 4 times 9 in the original equation, 4 times 9 is 36, and the square root of 36 is 6. But again, we're just teaching you the process that which it goes through for when you get to more difficult ones. Here's our next one. Now, in order to do this, the first thing you want to do is isolate the radical by itself on one side of the equation first. So as these begin to get a little more difficult, don't do anything until you have the radical by itself. Don't do anything to the radical until you get it by itself. So what we have here is the square root of a number plus 3 equals 10. So the first thing we want to do is move the plus 3 to the other side of the equation so we can get the radical by itself. Of course, the opposite of adding 3 is subtracting 3. So we're going to subtract 3 on both sides of the equation. That leaves us with the square root of a number is equal to 7. And as you know, 7 times 7 is 49. So if you square both of these sides, x is equal to 49. Which makes sense up here. If you go back and check it, because the square root of 49 is 7, and 7 plus 3 is 10. Now they're starting to get a little longer, so let's see what we would do. First, we want to isolate the radical. Here's the radical. We want to get it by itself on one side of the equation. So first we're going to have to move the plus 4, and the opposite of adding 4 is subtracting 4. So we're going to do that on both sides of our equation. That leaves us with 3 on the right side, and now we have the radical by itself, 2x minus 1. Now it's been taking the square root of that, so we're going to square both sides, which is the opposite of taking the square root. So the square root being squared cancels each other out. That just leaves us what's underneath. 2x minus 1 is equal to, now we have to square the 3. 3 squared is 9. Now you're left with a two-step equation. So we move with what is not attached to the x first. So we're going to add 1 on both sides of the equation. That leaves us with 2x is equal to 10. And then we divide both sides by 2. We see that x is equal to 5. So let's go back up here to the original and see if that makes sense. 5. 2 times 5 is 10, minus 1 is 9, and the square root of 9 is 3, and 3 plus 4 is 7. So it checks. So the important thing to remember is to always get the radical by itself on one side of the equation, and then you're going to square both sides, and then solve your two-step equation. Okay, now here we have the square root of x being multiplied times 3. Now again, we want to get this radical by itself before we do anything else. It is being multiplied by 3, so we're going to divide both sides by 3 first. That leaves us with the square root of x on the left side and 7 on the right side. Now if we square the square root, we square both sides because what you do to one side of the equation, you must do to both sides. Then you find that x is equal to 49. So let's check it up here. X is equal to 49. So 3 times the square root of 49 would be 3 times 7, and that is 21. So it checks. So in review, we divided by 3, squared both sides, got 49. Okay, so here we have a radical on the left side being divided by 3, and to get it by itself, first we have to multiply both sides by 3. 3 divided by 3 cancels out, so we have the square root of x is equal to 15. And then if we do the opposite of taking the square root, which is squaring, on both sides of the equation, because what you do to one side, you must do to both sides, you're left with 15 squared, which is 225. And that would check up here, because if we took the square root of 225, which is 15, and 15 divided by 3 is 5, which was the original equation. It's always good to go back up there and see if it works. This time we have a radical on both sides of the equation. So they're by themselves, one's on the left and one's on the right. So we're going to do the same thing we've been doing. If something's being squared, you have to use the inverse, or taking the square root. The opposite would be squaring. So we're going to square both sides. Well, what happens when you square something that's being taken the square root of? They cancel each other out. So on the left side, we just have x plus 1. On this side, you just have 3. So look what happens up here. Both of the radicals just go away when you square both sides. And now you just have a one-step equation, and x is equal to 2. So let's see if that checks up here in the first equation. If this is 2, you have the square root of 2 plus 1, which is the square root of 3, and that is equal to the square root of 3. Here you have two radicals, but they're on the same side of the equation. So we're going to have to move one to the other side first. This one's negative, so I'm going to move it to the other side. So that would give us on the left side the square root of x plus 8. And when I move this to the other side of the equation, it jumps this fence right here. I call this a fence. And when it jumps the fence, it changes to a positive. It changes to the opposite sign. So it becomes a positive square root of 3x. Now again, you have a square root on both sides, so if you square both sides, all that cancels out, and you just have x plus 8 on the left and 3x on the right. Now we have to solve for x. We need to get the x on one side, so I'm going to move this x over to the right side of the equation. That leaves us with 8 on the left side and 2x on the right side. Now x is being multiplied by 2, so I divide both sides by 2. And I see that x is equal to 4. Let's see if that checks out up here in the original equation. If x is equal to 4, we would have the square root of 12 minus, and we have 3 times 4, which is 12, minus the square root of 12 is equal to 0. It does check out. Okay, here we have the square root of 6 minus x is equal to x. So we need to square both sides. Now this one's a little different, so watch this one carefully. Okay, so to get rid of the radical sign, we have to square both sides. So taking the square root of something being squared, that cancels out, and you have 6 minus x left on the left side. And on the right side, you now have x squared. Now we have a quadratic equation. So in order to solve it, we're going to have to factor it. So I'm going to move this term to the other side, so that would be a positive x. I'm going to move this term to the other side, and that would be a negative 6, because when they jump the fence right here, they become the opposite sign. So now I have a trinomial. I have, let me erase that right there, x squared plus 6, or x squared plus x minus 6. To solve this, we factor it. We have a trinomial. The leading coefficient is a 1, so we use reverse FOIL. So we think of factor pairs for 6 that will add together, to get a negative 6, I'm sorry, to get a negative 6, but adds to get a positive 1. So if we do this, you would have x minus 2 and x plus 3. When we factor it, we're back to that factoring thing again. I'm going to erase all this because the PowerPoint leads you through it too. So there's where we squared both sides. We had to move it all to one side. We factored it. And now, remember that when we set it equal to 0, because this is a quadratic equation, and when solving, we set both of these equal to 0. And when you move the negative 2 to the other side, it becomes a positive 2. And when you move the positive 3 to the other side, it becomes a negative 3. So the solution would be negative 3 or 2. It started out as a radical, and it ended up becoming a quadratic equation that you solved. Now here's an example from application. The formula velocity equals the square root of 2 times em divided by m. Describes the relationship between an object's mass. So the small m is for the mass. It's right here and right here. Its velocity in v, so here's our velocity, in meters per second, and its kinetic energy, E is for kinetic energy. A baseball with a mass of 1,400 kilograms. So here's what we're going to plug into m. M equals this. Is thrown with velocity, so here's our velocity, here's our v, at 28 meters per second. So here's what our v equals. How much kinetic energy does the baseball have? So we're solving for kinetic energy, or for the large E. So what we're going to do is plug this number in for m, this number in for velocity. So in place of the v for velocity, we're going to put 28. Then we have the square root of 2 times the kinetic energy, which we're solving for, times the mass of 1,400 divided by 1,400. So to solve this, you see a radical here on the right side of the equation. It's being divided by 1,400. So the first thing we want to do is multiply both sides by 1,400. And what happens is this is going to cancel out this. So on the left side, we have 28 times 1,400, which is 3 9200. Use your calculator. On this side, we have the square root of 2 times 1,400. And if you go ahead and do the 2 times 1,400, you will get 20. Not a square root. We already have the square root sign. You would have, we're just multiplying the 2 times the 1,400. You would get 2,800. And then you're looking for the energy. Now you have a radical sign, so to get rid of that, we square both sides of the equation. These cancel out, and you're left with 2,800 E kinetic energy on the right. And over here you have 3 9200 squared, which when you type that into your calculator would be 15 3600. Now to solve for the energy, you divide by 2,800. And when you use your calculator there, you'll find that that is 54 88 hundredths. So you have to learn how to do these steps. Some of them earlier you could have probably looked at mentally and figured them out. But this one, when you have all these decimals, you need a process in order to be able to solve them. So there's the answer again. So just plug in the numbers and follow the steps that we talked about. This has been solving radical expressions.